Hi ho everybody, this is Mr. Ridpath here. We're going to work on maybe the last part of 11.6 and it's going to talk about odds. So when we talk about probability, we're going to talk about odds. So we'll kick you up onto the next slide and we'll see where we go from there. So before we go right into odds, let's talk about contingency table probabilities. So here is what we call a contingency table. Usually it's many categories of variables, and in this case, suppose we're looking at freshmen, sophomores, juniors, and seniors on a high school campus, and we're looking at the male and female categories. The most important thing with a contingency table is, in general, you have to continue the table and find the totals. So what I'd like for you to do is stop and add these up and find the column totals and the row totals and then the table total. And so hopefully when you added these up you got the same totals I got. These are correct. I double checked them while I was paused, and so hopefully you got these totals. Why are these totals so important? Well, say I want to find the probability of a male sophomore if I select one student at random. So I want to find the probability that someone is a male sophomore. Okay? Well, what that means is when I look at this table, I'm only going to see this number right here, 28. Those are the male sophomores. And so I know that the number in the male sophomore group is 28. So what's the total out of? Well, I want to find the probability of male sophomores on my campus. Then it would be out of 187, which would be the table total. But if I wanted to find the probability of male sophomores, given that they were already a sophomore, then my total on the bottom would be the column total. And if I wanted to find the probability of male sophomores given that they were male, then my total would have been the male total. And so these contingency tables give you lots of totals, and it makes it really nice to find certain probabilities. So let me give you another problem here, and you can try. So what I would like for you to find is find the probability of being a male junior or a female junior. So why don't you try that? So the first thing you need to think about is, are these mutually exclusive? And the answer is yes, since male juniors are completely different than female juniors. Now they're both juniors, but this is like saying it's a 5 of hearts and a 10 of hearts. They're completely distinct cards. If I was just talking about juniors, then it wouldn't be mutually exclusive. But since I said male junior, that's a distinct category from female junior, so it is mutually exclusive. Therefore, it's the probability of male juniors plus the probability of female juniors. And what are those numbers? Well, those numbers are going to be just what you would expect them to be. The male juniors are this category. There are 20 of them out of 187 total students. The female juniors are this category, which is 25 out of 187, and so that's going to be 45 out of 187. And that's how you do that kind of probability. Did you get that? If you did, you know what you're doing. Okay, next slide. So there are two kinds of odds. There are what's called the odds in favor, and there's what's called the odds against. And so what's an odds in favor defined as? Well, let's label it the odds in favor are equal to the probability of an event divided by the probability of not the event. And the odds against are essentially the reciprocal. They're the probabilities of not an event divided by the probability of the event. And that's how you figure out odds. So let's look at a quick problem. One of the problems in your book on odds says, suppose you roll one die. So we're going to roll one die. All right. And what are the odds of rolling a number greater than 2? So we want the odds of rolling greater than 2 on the dice. So what we have to first describe is, well, what's our event? Well, our event is the set. So the event is the set of 3, 4, 5, or 6. So now I know the event. So the probability of the event is equal to 4 out of 6, and the probability of not the event is equal to 2 out of 6. Because they're mutually exclusive, in this case they have to add up to 1. And so since we have that, we can now finish the problem. The odds in favor of rolling greater than a 2 are going to be, so we'll put odds in favor, are going to be the probability of the event divided by the probability of not the event. Well, remember that this means divide, so you could write this as 4/6 divided by 2/6, which is 4/6 times 6 over 2, which is equal to, once you do all the multiplication and canceling, in this case it's equal to 2. And so you would say the odds of rolling greater than a 2 are actually 2 to 1. So what you're going to get is you're going to get a number here, and then you compare that to 1. Or if you wish, another way to think of it is this is equal to the fraction 2 over 1. So the odds in favor are 2 to 1. So I really think probably good enough for this video. I'm going to upload it now, and it'll give us enough problems that we can do tomorrow in class. So I hope you enjoyed your day off, and enjoy the video. We'll see you next time. Mr. R signing out.